Hello, ladies and gentlemen. I just wanted to go over a quick example of solving a real-world problem in terms of quadratics by graphing, because we really haven't seen this since last Thursday. I hope everybody enjoyed the long weekend. I just want to go over this question before you start on the worksheet that I have left for you. It's not terribly long because these questions can get a little tedious, but yeah, let's begin. An architect is designing a museum entranceway in the shape of a parabolic arch, represented by the equation y equals negative x squared plus 20x, where 0 is less than or equal to x, which is less than or equal to 20, and all dimensions are represented in feet. So really important from that is the equation, the domain restriction, which means we're only graphing from 0 to 20. We will not be going past that, so no arrows on this one. The fact that it's a museum entranceway, not necessarily important for the computational work that we're going to do, but it's something to keep in mind because this is a little different than what we've seen so far. We've been talking about something called projectile motion, meaning it's like a ball or a rocket flying in the air. But this time we're talking about an archway. This is something that an architect would have to deal with. So on the accompanying set of axes, sketch a graph of the arch and determine its maximum height in feet. So we're actually going to find that answer to the second part of the question in the process of graphing this, but we will write it out as a final answer in the end. So we're going to start with the equation that's given to us. That equation is y equals negative x squared plus 20x. And we are going to graph that. We are going to figure out a table for that from 0 to 20. Now, we should know where the middle of this is going to be, where that vertex or axis of symmetry is going to be. It should be directly in the middle if we're designing an archway or an entryway. So if we think about what that would look like, if I am designing an entryway into a museum, it would be from 0 to 20 feet because that's how wide it would be. That's what it would look like. So hopefully directly in the middle would be 10 feet. Let's just confirm that by finding the axis of symmetry, which is x equals negative b over 2a. In this case, that is negative 20 divided by 2 times negative 1, or negative 20 divided by negative 2, which is in fact 10. So the middle here is going to be 10. What I'm going to do is I'm going to look at the table in my calculator first to determine which values I really want to plot. So if I look at my calculator, in y equals, I will type in negative x squared plus 20x, and I'll go and look at the table by hitting second graph, which will bring up my table. So looking at the table that we have here, we can see that it starts at 0, 0, and then it hits another multiple 5 at 5, 75. What we're going to do here is we are going to copy down our points at 0, 5, 10, 15, and 20. That should give us enough information about our parabola. We know 0, 0 is a point and 5, 75. So let's look at the value at 10, which is 100, and at 15, which is 75. And now at 20, we will hope it would be 0 because we want the arch to meet the ground again, or else it would look like a really weird door. So we get 20, 0, and now we can plot these. We have to first scale our y-axis, which talks about the height in feet, and then the x-axis will be the width in feet. We have 20 boxes here on the y-axis if you count them out, and we know that we need to get up to 100, so if we count by 5s, we will actually be perfect here. So we're going to have 5, 10, 15, 20, 30, all the way up. Notice how I am skipping a box. That's how I am keeping it consistently by 5s. You don't have to write all of them in. but it would be 90, 95, 100, for example. Now, on the bottom, we just have to get out to 20. There's also 20 boxes here, so we're just going to write down 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So our graph is actually going to look really nice here because it's going to fit exactly in this quadrant. This is the first quadrant of a coordinate plane. So now we're going to plot the points that we have: 0, 0, 5, 75, 10, 100, and then back again 15, 75, and 20, 0 here. So we're going to connect those best we can as a parabola. Ugh. Doesn't look great, but that is what the archway would look like. And you can see right here we have a maximum. So the max height is 100 feet. And there we go. We've answered all parts of the question. And now you can see that quadratics can be used to solve more than just projectile motion questions when we're talking about real-world problems. If you guys have any questions, please make sure to ask them either in the chat or on Google Classroom. Send us an email. We do like to hear from you, and we do like answering questions, so let us know if you have any questions. All right? Have a great day, ladies and gentlemen. Take care.